All right, so I made some progress. I want to pretty much call it done. So I have my sad little aluminum coupler. Focus, you fuck. There we go. That I made. It is not concentric because I made it with a wood lathe. So that is instilling some side load on the throttle position sensor. I'm surprised at how strong the spring is on just this throttle position sensor. It is a unknown brand. Oops. It's an unknown brand. I just went and said, I need a cheap throttle position sensor, so I have no idea what it is. I gouged it out enough that I could attach some wires to it because I didn't have an appropriate connector to go with it. So this is just Allen wrenched onto the top of the doolally here. But the inside of the throttle position sensor had a it was like a circular profile with a keyway on both sides, a triangular keyway. I had to machine that as well with a file, like a savage. Anyway, so now I'm still using my crappy pot over here, but now it moves how I want it to. It has fairly fine granularity. I turn it nice and slow. So basically this is just, I'm requesting a analog value with the thing on with the pot on the right, and it is just stepping until it reaches that value from the potentiometer, or from the throttle position sensor on the left. If you look real close, I don't know if you can actually see it. Oops. You can actually see the pieces of metal moving apart from each other due to the inaccuracy in my milling. So that's making it actually harder for this thing, and it meant I had to crank the voltage on the stepper up a little more, or whatever, the amperage up on the stepper a little more. So this is just a little tiny controller here, and it's got a little dinky heatsink on it, and it is it's pretty hot, but they say it's rated for up to 2 amps, but you know, that is yet to be seen. So I imagine if I had a better pot on this side, it would be even better, but anyway, so the weight, stop wiggling. So if you look up here, I have an open value and a closed value, and those are, you know, this is a 10-bit analog to digital converter in the Arduino, so it returns a 0 to 1024. So basically anything less than 50 I'm calling, you know, the end, and anything more than 1,000 I'm calling the end. Then I have that overlap amount there, and that is, if you don't have something, it'll sit there and just bounce around like while it's trying to decide which way to go. Because if you come down here, I mean, it's pretty simple. I just have desired, this is where it reads the 2 analog sensors. We say if the desired angle is greater than the closed value, then set it to the closed value. So that's our 50 and 1000 numbers up there for these two. Then down here I say if actual angle is greater than or equal to the desired angle plus the overlap amount, then move it. If it's less than the desired angle minus the overlap amount, move it the other way. And that is it. So you can screw with the overlap amount as much as you want to make it, because I'm not sure how good the pots are in the throttle position sensor you have. I'd imagine it's probably better than this one. But anyway, that, oh yeah, this right here, these two define the pins on the Arduino as to what their analog inputs are. Actually, LED pin isn't even a thing, and neither is sensor value at this point. So anyway, I can get rid of those 2 lines. Anyway, I thought I'd show you how that works. I don't have any sort of error checking in here at the moment, so I will have to see, because I'm pretty sure right now if you lose power to the pot, it goes to wide open throttle. So I'm not sure how to use some sort of health status on that, because I believe 0 is, like 0 volts is 0 out of 1024, and the pot, when it's wide open, or the throttle position sensor this here, when it's wide open, is reading 0. So when it's closed, it's reading 1024. So I wonder if I just switch the two analog wires. I'll have to take a look at that. Anyway, that's it for now. Bye.